blanco.
Jesse, we're gonna need beakers, flasks, a weighing scale, a gas mask, that one too.
But Mr. White, what does all this stuff have to do with what we're doing?
Jesse, it's easy. With this sodium carbonate and calcium chloride, we can easily create a precipitate. What?
Mr. White, this is the cleanest calcium carbonate I've ever seen. Swag. Mr. White, we gotta get out of here.
They probably got me down by the end of the song. Seem like the whole city go against me. Every time I'm in the street, I hear God.
Mr. White. Yo, Mr. White. Yo, Mr. White, I still don't see what this has to do with what we're doing.
Jesse, it's obvious. Haven't you been in an AP chemistry class?
Now, Jesse, why don't we start off with some calcium phosphate? There's a KSP of 2.0 times 10 to the negative 29th power. From this information, we can set up an equilibrium equation of calcium phosphate solid yields 3 calcium 2 plus 2 PO4 3. Jesse, come back here! I am the one who knocks! Anyway, notice the 3 and 2. We can set up our icebox as follows. Calcium phosphate does not contribute because it's solid. Initially there are 0 ions, but after a change there's a 3x and a 2x. Therefore equilibrium is 3x and 2x. From our KSP equation we can yield KSP equals Ca2 plus to the third power times PO4 3 minus to the second. Therefore 2.0 times 10 to the negative 29 equals 3x cubed times 2x squared. 2.0 times 10 to the negative 29 equals 108 x to the 5th. A little algebra, and x equals 7.13 times 10 to the negative 7th moles per liter. Now let's apply what we know with calcium carbonate. Calcium carbonate has a KSP 4.8 times 10 to the negative 9. Setting up our equilibrium equation, we have calcium carbonate solid yields calcium 2 plus aqueous plus carbonate 2 minus aqueous. Once again, we set up our icebox. Calcium carbonate does not contribute to the KSP equation due to it being solid. Both initially are 0.1 molar, there's a change in X, and therefore equilibrium is 0.1 plus X for both ions. The change is so significant compared to the initial that we can disregard them in our equation. Our KSP from our equilibrium equation is calcium 2 plus times carbonate 2 minus. And from this, we can gather that QSP is equal to 0.1 times 0.1, also known as 0.01. With our information in hand, we can say that QSP is equal to 0.01 and KSP is equal to 4.8 times 10 to the negative 9. Therefore, Q is greater than K, and precipitate will form. Exactly what we want, Jesse.
Señor Blanco. ¿Qué es esto? Bien, señor Blanco, va a comprar 500 unidades.
Thank you, Senior Pantalones. We'll make your product right away.
Inténtelo, señor Blanco. I will speak to you in English. This is a 6-round Nerf blaster. It cannot kill anyone, but if I shoot you in the eye, it will hurt very, very much. I too was a chemistry teacher once, and whenever I got to chapter 16, my students always struggled with this one question.
Well, what do you want?
What is the relationship between KSP and solubility?
KSP is the product of all the solubilities of the ions in moles per liter.
Es cierto, señor Blanco. Now let's see if bullets are body soluble.
What you say? Oh, that you only meant well. Of course you did. What you say? That it's all for the best. Because it is. What you say?